Chapter 9, Section 1, we're talking about two formulas you'll need to know of two of the many formulas in Chapter 9 you'll have to memorize. So please memorize them each day as we go. We have the distance formula and we have the midpoint formula. So don't let these formulas get too distant from your memory. So to start with the distance formula, we're going to take something you already know and move you forward to something new. That's called transference of learning. So if you remember the Pythagorean theorem, says if the length of the hypotenuse of a right triangle, we're going to represent that by the letter C. Lengths of the other two sides are A and B. Then C squared equals A squared plus B squared. That is true. What we're going to do, though, is apply that, and just to refresh your memory, there's the little picture. C squared is the longest side, the hypotenuse, equals A squared plus B squared. There is a joke, but it's too long to tell right now. All right, so what we're going to do is try to apply that to a point on the graph. So let's take 2 points arbitrarily on the graph. I just selected 2 points, doesn't matter which they are. We're going to make them generic because we're looking for a formula. So rather than saying that's 0.44, which it is, I'm going to pretend we don't know that. We're going to call that point x1, y1. And we're going to pick some other arbitrary point, call it x2, y2. And one of the things we want to learn is what is the distance between any 2 points on the Cartesian plane. How does that tie in with the Pythagorean theorem? Well, simple. We have horizontal and vertical representations. So we can draw a vertical line, we can draw a horizontal line. Horizontal and vertical are perpendicular to each other, so that gives us our nice right triangle. How do we find the length of this side right here? Well, since this side is going up and down, it's y values. All we have to do is subtract the y values. Does it matter the order you subtract the y values? No. But what's important is after we subtract those y values, we're going to take the absolute value of it, because distance must be positive. It can never be negative. Likewise, then, to find out how large the horizontal component of this triangle is, we're going to do the same thing, only we're going to subtract the x values. Doesn't matter which order, as long as we make it positive, in this case by taking the absolute value of it. And then we've got the distance for the hypotenuse is going to be the square, the sum of the squares of the other 2 sides. So that's where the Pythagorean theorem fits in. So in this case, we've got c squared equals a squared plus b squared. Instead of leaving it that way, we're going to solve for c. And the way to do that is to square root both sides. So what I'm essentially doing right now is deriving the formula. You will not have to derive it, but you will have to know it and know how to use it. So instead of c, the hypotenuse in my graph, I'm representing as the distance. And then the other 2 sides, a squared plus b squared, I'm going to substitute in the difference of the x values, x1 minus x2. I'm going to substitute in for the other side, y1 minus y2. And those quantities need to be squared according to the Pythagorean theorem. And I'm going to abbreviate distance as d. And some of you might observe, well, wait, what happened to the absolute values? You don't have them anymore. The answer to that question is you don't need them anymore, because you just need to guarantee that the length of those sides are positive. Anytime you subtract a number and square it, a positive times positive is positive, a negative times negative is positive. So squaring any number gives us that positive result. So that is deriving the formula. You will not have to derive the formula, but you will have to memorize the formula and know how to use it. So let's look at one of those examples. Find the distance between the point 8,7 and the point 3, -5. Now, the long way of doing this is to draw the points on a graph. No point in doing that. We have a formula. What we want to do is label one of those points point 1, one of those points point 2, just so we are consistent. So d is the square root of the difference of the x values. So I'm going to say x sub 1, 8, minus x sub 2, 3, and I'm going to square that quantity. Then I'm going to subtract the y value, so y1 is 7 minus negative 5, and we're going to square that. Don't forget, subtracting a negative is the same as adding a positive. Let's simplify what's in parentheses first. 8 minus 3 is 5. 7 plus 5 is 12. Now we've got to simplify our exponents next. 5 squared is 25. 12 squared is 144. Before we can do anything else, we need to do the addition under the radical sign before we take its square root. 25 plus 144 works out to be a nice 169, which you should have memorized ever since chapter 4 as our list of perfect squares. Square root of 169 is 13. However, the homework problems or the test problems may not always work so easily. So again, chapter 9 test will use a scientific calculator, and you want one that has a square root button on it. And that's the distance formula. Simple thing, simple question, as long as you have the formula memorized. You don't have the formula memorized, you're not going to be able to do well on this question on the test. So memorizing the formula is the tip of the iceberg, and we'll need to practice them. That's the continuation. Midpoint. Well, remember from geometry, then we had something about a midpoint. So here's the formula for the midpoint. We're not going to do any geometric constructions, but if we had 2 points arbitrarily on the Cartesian plane, why not call them x1, y1 and x2, y2 while we're at it? Of course, with a compass, we could find the perpendicular bisector, which would give us the midpoint, but we want an exact value, and it may be a decimal, and that would be hard to guess by a graph. So the formula for the midpoint is actually very easy to memorize. You are essentially averaging the x values, because remember, average, the mean, means add the scores together, divide by how many there are. There are 2 x values. We're adding the 2 x values together, dividing by 2. There are 2 y values. Add them together, divide by 2. And that's the formula for finding the midpoint of any 2 points. So we only need one simple example for that, since this is fairly easy. No need to graph, no need for compasses and protractors and constructions. All we've got to do is call one of those points point 1, the other point 2, so we're consistent. And we're going to average the x values. Negative 3 plus 4 divided by 2. And average the y values, 5 plus negative 7 divided by 2. So negative 3 plus 4 is 1 over 2. 5 plus negative 7 is negative 2 over 2. And of course, all our fractions need to be simplified or reduced. So the midpoint of negative 3, 5 and 4, negative 7 is the point 1/2, negative 1. That's the distance formula and the midpoint formula.